Physical and chemical properties. What's the matter? Chemistry is the study of the properties and the composition of matter. This has historically been difficult because observations could not be directly made due to the extremely small size of matter. As early as 400 BC, Democritus, a Greek philosopher, believed that a substance, for example, a piece of chalk, could be continuously cut into smaller and smaller pieces until you reached the smallest possible component of the substance. He called these invisible particles atomos, meaning indivisible. Over the centuries, scientists observed the behavior of particles in water and smoke, and they formulated the particle theory of matter, which states that matter is made of very small particles. Particles are in constant motion. Particles move faster at higher temperatures and slower at lower temperatures. Particles of each pure substance are identical to one another and different from the particles of all other pure substances. Particles attract each other. Democritus first described particles. The material that makes up your computer, MP3 player, and the air you breathe is all made up of matter. Matter exists in one of three states: solid, liquid, or gas. All matter could be classified into two different groups: mixtures or pure substances. Ancient Asian and Japanese cultures believed that all things, or matter, were made up of the four elements: earth, air, fire, and water. The classification of matter. Matter can be homogeneous, which are pure substances, and mixtures that are of a uniform composition throughout, or heterogeneous, which are mixtures that do not have a uniform composition throughout. Pure substances contain only one type of particle. Elements are composed of only one type of atom. For example, sodium, Na, carbon, C, sulfur, S, and helium, He, are examples. All of these elements are found in the periodic table, which we've earlier discussed. Compounds are composed of one type of molecule with two or more atoms from different elements. Example, sodium chloride, NaCl, also known as table salt. Molecules are composed of sodium and chlorine atoms bonded together. Mixtures contain two or more kinds of particles. There are two general classes. Homogeneous mixtures, or solutions, are mixtures with only one visible phase. That is, you can only see one component. For example, when you make cherry Kool-Aid, the crystals are dissolved into the water and the solution appears as a single red liquid. A solution has two components, a solute, which is the substance that is being dissolved, and the solvent, which is the substance that is dissolving the solute. So in the Kool-Aid example, for our purposes, the crystals are the solute and the water is the solvent. Did you know? Metal alloys are homogeneous mixtures of different materials that are mixed in a solution before cooling and hardening. Steel is a mixture of iron, which rusts and is soft, and carbon, which makes the metal much stronger. Gold jewelry is also a metal alloy in which copper is added to the gold to improve its hardness. Mixtures. Heterogeneous mixtures have more than one visible phase. Heterogeneous mixtures may be easily identifiable as with granite rock. However, in some instances, the initial observation and identification of a suspension, colloid, or emulsion may be that of a solution. In a suspension, the small particles that are barely visible with the eye, and if left undisturbed, the suspended particles will eventually settle out. Many of the products found in your fridge that instruct you to shake well before using are in fact suspensions. The shaking causes the particles to become suspended. For example, if tomato juice is left for a long period of time, it would develop two layers as the tomato settles to the bottom. Colloids contain suspended particles that are so small until they do not settle out. For example, in fog, the water droplets are not small enough to be dissolved by the air, and they are not large enough to fall as rain droplets. Emulsions are a type of colloid in which tiny liquid droplets are mixed with another liquid. Milk is an example of an emulsion in which drops of cream are mixed with water. An emulsifying agent could be used to prevent separation. For example, an egg yolk is used in a mixture with oil and vinegar to produce mayonnaise. A chemical in the egg yolk keeps the oil and vinegar from separating. In order to tell the difference between a solution and a colloid, you can shine a light through the solution. If the light is scattered, it is a colloid. This is called the Tyndall effect. Physical and chemical properties. What is the difference between pouring syrup and pouring a glass of water? Well, the syrup is thicker and flows more slowly compared to the water. This is an example of a physical property called viscosity. All substances have characteristic physical properties which can be detected with your senses or are measured with some tool. Observations made with measurements where a numerical value is obtained are called quantitative observations. And general observations made by your senses, such as color, are called qualitative observations. Color. The hue of a substance. It's a red, yellow, blue, etc. Luster. The brightness or shininess of a substance. State of matter. The phase the substance is in, solid, liquid, or gas. The state of matter is usually given when the substance is at room temperature, because most substances will have different states of matter at different temperatures. Take water, for example. It is a liquid at 20 degrees Celsius and a solid below 0 degrees Celsius. Taste. The flavor of a substance, is it bitter, sweet, sour, etc.? In a science lab, taste is never used as an observation because of the possible toxic properties and contamination of the unknown substances you are investigating. Odor. The smell a substance has. Texture, the feel of a substance to the touch. Is it smooth, coarse-grained, fine-grained, etc.? Malleability, the ability of a hammer to bend a substance into other shapes. Most metals will bend and can be shaped. However, some substances are brittle and break when hit with a hammer, especially something like glass. Density is the amount of matter per unit of volume. Another term is mass. Density can be expressed as an equation. Density is mass divided by volume, or if you prefer a formula, D equals M divided by V. The measurements are often expressed as grams per centimeter cubed. Melting, freezing, and boiling points. The states of matter could change between solid, liquid, and gas at varying temperatures. These temperatures are constant for each substance, so can be used to identify it. Hardness, the measure of the ability of a substance to resist scratching. Hardness is measured on the Mohs scale and may range from 1, the softest, to 10, the hardest. Next is solubility. The ability of a substance to be dissolved in a liquid solvent such as water, measured as the mass of solute per mass of solvent. Conductivity, the ability of a substance to conduct heat or electricity. Viscosity, the measure of how easily a liquid flows. For example, honey flows more slowly and has a higher viscosity than water. Ductility. This is a measure of how easily a substance can be stretched into wire. Did you know A diamond with a hardness of 10 is the hardest substance on the Mohs scale, and it is this property that makes diamonds useful for drilling companies. Drill bits are embedded with diamonds to help with drilling through rock. In comparison, graphite is at the other end of the scale with a hardness of 1. Graphite's soft nature allows it to be used as a writing tool. Despite the vast difference in their hardness, both diamonds and graphite are composed of carbon atoms. That's interesting. It is the arrangement of the carbon atoms and how diamonds and graphite are formed that produces the difference in hardness. Chemical properties. A chemical property describes how a substance reacts with another substance in a chemical reaction to form a new substance. Some examples of chemical properties include how the substance reacts with water, air, pure oxygen, and acids. Other chemical properties may include the toxicity, stability, and combustibility. Sometimes the most important uses of a substance are from a reaction that it has with something else. For example, when wood burns in air, we get fire, which can be beneficial to us if we use it for heat, light, or cooking. Mixing ingredients together to bake bread or cookies is another reaction that is beneficial to us, and yes, it's yummy. The most common types of reactions are with water. Most elements and compounds do not react with water. However, water is an important solvent and will dissolve many different compounds. Solubility. Hydrolysis reactions in which a water molecule is added to break down larger molecules are an important part of biological processes. For example, during digestion, enzymes weaken the bonds between molecules in a large chain, and water is inserted to break the chain down into smaller pieces. Who knew? Oxygen. Most metals will react in the presence of oxygen to produce a metal oxide. Rusting is a result of the reaction between iron and oxygen to produce iron oxide. Acids. Most metals will react with acids to produce a salt and hydrogen gas. Combustibility or flammability. This is the ability of a substance to burn in air. Under ideal conditions and with pure fuels, the only products that carbon dioxide and water. However, in most instances, other products of combustion can include carbon monoxide, sulfur dioxide, nitrogen oxides, and particulate matter. All of these particles can affect human health and are a cause of acid rain. There are two different ways that substances change when they are mixed together. Physical changes occur when the substance has been changed in some form, yet remains the same substance chemically. These changes are usually easily reversed. For example, changes of state are physical changes because the substance remains the same chemically. Water as a solid, liquid, or gas is still H2O, and the change from one state to another is easily reversed. You could put water in a freezer to change it from a liquid to ice, and simply place the ice on the counter to allow it to melt and change back into a liquid. Chemical changes result in the original substance being changed to an entirely new substance with different properties. These changes are not reversible. For example, when you burn a log in a fire, the log turns to ash and heat. Carbon dioxide and water vapor are all released into the air. When you fry an egg, once the heat is added, you are not able to get the original egg white and yolk back. There are 5 clues that indicate a chemical change has taken place. 1. Heat or light is given off. 2. A color change occurs. 3. A precipitant or solid forms in the mixture of the 2 liquids. 4. Gas is produced, usually seen as bubbles in a liquid or vapor given off. And 5. The change is difficult or impossible to reverse. Let's talk about a Canadian contribution. One night in 1956, John Polanyi, a chemical lecturer at the University of Toronto, was the first to witness the production of light from a chemical reaction. Along with a graduate student and in a closet in his laboratory, he observed the release of a small amount of light from the reaction of hydrogen with chlorine. This light produced was called chemiluminescence, and because Polanyi understood the source of the emissions, he was able to apply the energy needed to allow the reaction to take place. Over the years, his experiments led to the development of many different lasers, and he was awarded the Nobel Prize. Read more about the life of John Polanyi.